Okay, let's go back in time to 2013. The database world had pretty much hit a brick wall. You see, just making processors faster, well, it wasn't cutting it anymore. The whole industry was staring down a crisis it just couldn't outrun, and it was desperate for a totally new way of thinking. And that's the exact moment the Exadata X4 arrived.
And this one line, it just perfectly captures the entire problem of that time. The challenge wasn't some single slow transaction or one super complex report. No, the real drama for these massive companies was just grappling with sheer unprecedented scale.
So systems were starting to choke. And the really interesting part? It wasn't because of some single monstrously slow query. No, that wasn't the problem at all. They were collapsing under the weight of thousands of perfectly normal, reasonable requests, all hitting them at the exact same time. And that right there was the concurrency crisis.
I mean, just think about that for a second. What really happens when your everyday customer transactions, your OLTP, are fighting for the same resources as your heavy-duty analytics and your big reporting jobs all at once? Well, before the X4, the answer was almost always the same thing: complete and total gridlock.
This is where Oracle comes into the picture, with a very specific, almost custom-built solution. You see, the Exadata X4 wasn't just another server they were rolling out. It was what we call an engineered system, hardware and software designed to work together as one single unit to solve this exact problem of massive concurrency.
So how did it actually fix this gridlock? Well, it wasn't just one magic trick. First off, it massively expanded its flash cache, which meant all the most used data was right there, instantly available. Second, it supercharged its Smart Scan feature. This basically made the storage itself intelligent, so it could filter out data you didn't need before it ever had a chance to slow down the main database. And finally, it acted like a really sophisticated traffic cop, managing all the different jobs to make sure that critical transactions and heavy analytics could run side by side without crashing into each other.
And this is the most crucial part of the story. The X4 wasn't just a simple evolution. It was a genuine paradigm shift in how people thought about engineering. The goal wasn't just about raw speed anymore. The new goal, the new obsession, was massive parallelism.
So, what in the world is parallelism, anyway? Well, the concept is actually pretty simple. It's about doing lots of things at once, instead of one after another. The highway analogy is perfect here. For years, engineers were just trying to make a single lane faster and faster. Parallelism comes along and says, forget that. What if we build a 16-lane superhighway instead? Then thousands of cars can all move at the same time. That was the big idea.
And this really shows you the change in thinking. The old way was kind of like a reactive game of whack-a-mole. You find a bottleneck, you fix it, and then you wait for the next one to pop up. The Exadata way was totally proactive. It was about designing a system from the ground up where thousands of queries could just run together in harmony, all orchestrated and balanced by the hardware itself.
But look, this wasn't just some theoretical achievement for engineers to admire. This new kind of power had a huge real-world impact on the most demanding industries out there. Everything from high-frequency trading on Wall Street to the massive billing systems in telecom.
Just picture this for a minute. You've got a financial analyst moments away from a massive market decision. They need to run hundreds of different models and queries all at the same time. There's no time to do them one by one. They need the answer right now, and it has to be based on all the data at once. That's exactly the kind of high-stakes problem that massive concurrency was built to solve.
And this quote just nails the payoff, doesn't it? The whole point of mastering parallelism wasn't about getting a slightly faster report. The real win was a fundamental change in what was even possible. It enabled entire new workflows that businesses could have only dreamed of before.
So as we start to wrap this up, it's pretty clear that the legacy of the X4 is about way more than its own impressive performance. It really cemented an idea that would go on to shape system design for the next decade.
And here's the core lesson, right here. The Exadata X4 proved, without a doubt, that the biggest breakthroughs weren't going to come from just a faster chip or a cleverer piece of software on its own. Nope. Real performance at a massive scale was going to come from co-engineering the hardware and software together, creating a system that was truly more than the sum of its parts.
And of course, the story didn't end there. Those principles of parallelism and co-engineered systems that the X4 proved were so powerful. Well, they became the blueprint for the future, leading directly to its successor, the even more ambitious Exadata X5.